In this lesson, we'll be going through another theorem similar to the center theorem, the one which says angle at the center is 2 times the angle at the circumference, and it is often confused, but I will clear that misconception. So remember in the past or in the previous lesson, for the one where we said the angle at the center is twice the angle at the circumference, we said that here will be like this, right? And if at the circumference we've got 30, at the center we'll have 60, right? That's what we said. And again, we said that if it's given in this form, still it doesn't change. If here is 30 again, here it will be 60. So now there is this theorem very similar to it. So let's say you are given this thing like this now. Okay, I'm sorry for the bad drawing there. And the other one, which is like this. I want to check something. Let's say here is the center, right? So, guys, these things are not the same. Like situation 1 and 2 are not the same, right? They have the same shape, but this one here is not at the circumference. You see, like it's like the corner is hanging, but this one, both ends are at the circumference of a circle. So what we say that two angles which are at the circumference of a circle are the same, or angles which are on the same segment are the same. Okay, what's a segment actually? Let's see. So we say that this angle here is equal to this angle, and we say they're on the same segment. So if you check this position, this here and this position, they're on the same segment. Can you see it? Because if you move from here, let's say this point A and this point B, if you move from this point and you go up there, and you move from here and you go up there, they give you this angle here. Let's say it's X. Alright? Similarly with a different color. If you move from this point A, but now heading in that direction, and now you move from B again, go into that direction, you still have this angle X. Because they come from the same segment, we say that they are equal. They are subtended by the same arc, which is this arc, right? So because they are from the same arc, they are the same. Even if this arc will be like this, let's say it subtends another angle. Let's draw it. So let's say it now subtends this one here. Well, because it's still coming from the same arc AB, it will still be X here. Okay? But not this, because this one, they are not on the same they're on the same segment, but the other one is not on the circumference. So there's an exception. Therefore, the rule won't work in this case. So for it to work, both two endpoints must be on the circumference of a circle. So let's have an example. Suppose we are given a larger circle and we are given let's say here it's A, it's B, it's C, it's G, it's E, and it's F. So if C, it's X. Let's check. What arc subtends C? Well, it's this arc here, arc EF. So let's check. Does EF subtends another angle? Yes. It subtends A, B, C, and D. Therefore, here it's also X, also X, also X. Clear, right? So you must know from now that angles in the same segment are equal, or they're the same.